No, medyo Hello, everybody. Welcome back. Happy Friday.
Professor.
Yes, hello. I'm increasingly loving Fridays. Because, I teach on Fridays now. All righty. December 4th. Yes. All right. Ooh, look at all these cameras. Love it. Absolutely love it. Where am I? All right, let's start somewhere in the middle on the list of the roster. Zach?
Here.
DS? No. Jada?
Here.
Okay. Yuzhan?
Here.
Wendy? Lucas?
Here.
Taylor?
Here.
Okay. Ashley?
Here.
All right. DS might be having connection issues. Thank you for letting me know. All right. Let's see. Oni? I do see you. Chat me if your audio is not working. Nikki?
Here.
Gloria? Has anybody been in touch with Gloria? I haven't seen her, I think, 3 weeks in a row. Do any of you guys, Marco, you like got everybody's Instagram, right?
Yeah, I tried to add her to a group chat, but it wouldn't let me.
Oh, if anybody knows Gloria, then let me know. Oh, it's not 3 weeks in a row. I guess it's like just last week and then maybe today. Okay. Sienna? No. Okay. Chansey? I do see you.
I'm here. Yeah,
yep.
I'm here.
Wei?
Here.
Okay. Kaylin?
Here.
All right. I'm losing my sight, maybe. Delia?
Here.
Okay. Yes, Oni, I see that you're here. Maranke? No. Ariana?
Here.
Leslie? Robert?
Here.
Okay. Ava? Yasmin, you know you're here. Robert is here. Ava is not here. Where is everybody? Marco is here. Elliot?
Here.
Okay, so I don't have so far, unless you just came in, I don't see Ava, Leslie, Moronke, Sienna, and I think DS is having connection issues. Zach, are you here? Oh, I think Zach's here.
Yeah.
Yeah, okay. And then Samantha, are you here?
Yeah, I'm here.
Okay, and then Gloria, are you here yet? No? And then Wendy, are you here? Oh, I think I see Wendy now.
Here.
Okay. All right. Guys, you know what I thought of just now? So many cameras are on, it's so good. We should choose a time, a date, so you can get prepared if you want, and have all of our cameras on and take a screenshot. And I'll send it to everybody. And you'll have like a little bit of a memory, a memorabilia of this semester, you know? Don't you want to know? You can go back and be like, oh, I've never known this kid in this class because I never seen their cameras on. But we should do it at least once and get a screenshot, don't you think?
It's kind of funny how you mentioned it, Professor, because I was texting everybody on the group chat yesterday and I was like, we should have a day where we all turn on our cameras.
Yeah, and then we can all get a screenshot. I actually do that. So I've done that in like research meetings. Well, they know me well. And I would mute myself and I just take screenshots and they have no idea. And then like text them later and they're like, oh my God, Maria, that's like virtually illegal. And I was like, no, it's not. Because our session was recorded as well. But it's like funny because then I can get candidates. It's kind of cute. But anyways, I won't do that to you guys. I have not done that, mostly because they're black boxes. But we should set a date so we can do that before the end of the semester, which is approaching.
Yeah, I like that. That's a good idea.
Yeah, so let's do it. What are you guys? Wednesday, Friday. So let's do it like next week.
Yeah.
Wednesday or Friday, okay? I'll send out a reminder so you can all look pretty and everything, okay? The thing is, you guys don't know this because you're so young. When you're this young, you're just naturally beautiful. When you get to my age, you can't see, you're like limping all the time, you don't remember stuff, hair is like gray and like, basically you're dying. You're like basically half corpse. Nothing's beautiful, but you guys are so young. So it's just like you got that natural glow. You know what I mean? But you don't know that when you're young. When you're young, you're just like, oh, I'm insecure and I'm not pretty, but you'll know later. It's a little sad, isn't it? Because when you're young, you want to know that. Maybe you do know that. I don't know. Like love yourself, right? BTS is always like, love yourself. Anyways, so it's a good motto. I think you guys should love yourself. Why not? It's like, you never know when the end of the world is going to be. I love yourself.
That's true.
We're in college. I feel 40. Ashley, why do you feel like you're 40? You have no idea what 40 means. I don't even know what 40 means. I'm not 40 yet. I have no idea what that means. You don't know what that means at all.
Professor, can we ask, how old are you?
You can guess. I always love to do this because it's so awesomely offensive. I love it. No, it's not. I am
29.
29. Okay, I have a 29. What else?
What year were you born, Professor?
That doesn't count. You guys know how to count.
Okay. 35.
35. I have a 29, a 35.
31.
30s,
30s.
32, 30,
34.
34. Is that your final guess, guys? Oh,
41.
Early 30s. What?
Early 30s.
Early 30s. Early 30s. I think I'm. What did I just turn? I stopped counting. I was born in 84, so that makes me what? 36. I think that makes me 36, right?
We're close.
Yeah, you guys are not bad. I was hoping.
Yeah.
Chancey said 29, right? Chancey gets extra credit.
Professor, please know your age, though. I'm so concerned if you don't know.
Well, the thing is that after a while, it doesn't really matter, right? Usually when it matters is like, can I vote? Can I drink? Can I get a license? You know, like there's like really crucial moments where it counts. After all of that is legal, like what is there that you really care? I do get so excited when I'm carded at a bar because I feel young. They're like, it's just policy.
Yeah.
Don't
Also, like, you could like, if you want to avoid a midlife crisis, just stop counting. You know what I mean?
I have not had a midlife crisis, so
And it
yeah,
works.
when that happens. When
Yeah,
does
let us know-
does that happen in your 40s? I don't really know. Anyways, why are we talking about age right now? I don't know. Okay,
You mentioned you were not 40 yet.
I was not 40. Oh, because Ashley, you were like, I feel 40.
I feel 40 also.
You know, as my dear friend would say, you know, you young people, and she was telling me this as if I'm young, and like, you know, like you need to like just, you got so much energy, you're young, you know, sleep is for like she said a worse word, but like, you know, sleep is for like losers. You sleep when you die, you know, just bulldoze through it, right? With that energy, young energy. So all my students are always like, we're always sleepy, professor. I get not enough sleep. I need 8 hours to 10 hours. And I'm like, that's a lot of hours, guys. But you know, if you can, you're saving a lot of commute time, so maybe you can sleep more. Okay. Oh, regression. Okay, so let's start with the review. I will send out an email about taking a group screenshot. It kind of feels like, you know, in graduation, you all take a screen, a picture together. I feel like that's what I feel like. Group screenshot.
I can't relate. I mean, I never really had a graduation.
Yeah, me neither.
Oh, that's right. Oh. Don't worry, it's overrated. Really, what matters is at the after party after the graduation, which you will
We
eventually
even have
do.
an after party, Professor.
Well,
There
you-
was no graduation.
You
to have
can
an
you can
after
have
party.
like 10 because now you have an excuse to have like multiplied by 10 parties when there's a vaccine because it's like, well, I didn't get it at the right time. So your parents would be like, oh, okay. So you might get
We
more
didn't have
parties.
prom. We didn't have prom.
Oh,
No,
that's
no, no,
right.
no
Oh my God, you guys
graduation.
are so young. Prom. Oh my God. Oh
You don't know
God.
what that is.
I barely know what that is. Oh God. I went to like a really weird kind of school where there wasn't really a prom. So it was like, we were all all weirdos, did our own thing. Way too unique. Too school for cool. Too cool for school. Okay, guys, so let's start with a review. So we're gonna try to finish up regression today, hopefully, and we're gonna dig a little bit deeper into correlation, but not too much. And I think that would be a good wrap for regression. And then I can focus on doing a lot of problems with you guys. And then you guys are Wednesday, Friday. So yeah, and then I can give you a lot of class time to do problems, ask a lot of questions, and then we'll do a final review from the top, starting from population and statistic, and then you're good. You'll be done. Okay. Just another reminder, remember it's the 18th that you're taking the final, guys, right? Your Wednesday, Friday classes. So for Friday classes, the last day on the FIT academic calendar is December 18th. So just keep that in mind. It's approaching. All right, so
Professor,
what do
will
we
we
know?
get our,
What?
sorry, will we get our scores immediately after the final?
For the final?
Yeah, do we like, is the test immediately graded?
Don't you, when you guys do Lumen, I know after you submit each question, you can see if you got it right or wrong, right? Doesn't that mean that you can see your total score too?
Yeah, we can. I was just wondering if it's going to be the same thing for the
I
final.
will. I'll make it the same. I'll make it the same so you can see right away. Okay. Yeah. And then you can have an idea of like where you stand because you know what your midterm 1 is, you know what your midterm 2 is. You guys been all pretty much doing fantastic in all the problem sets, mostly because I messed up and you guys are getting full credit. But even when that was not true, you guys were doing really, really well. And participation, your class has always been really top notch, and you know, nobody has had too many absences from the attendance sheet I have that will affect their grades, right? So I think I would say pretty much majority of you guys are gonna come out strong if you really don't tank the final, which I don't think you will. We'll get plenty of practice, okay? Let me just, I've heard a few ding dings. Is Diaz here now? Or is having, oh, Sienna's here now, okay. Chat me if you like are here now and missed attendance. Okay, so I fixed that for Sienna. After the vaccine comes out, I'm partying overnight till 5 a.m. Good for you, Nikki. I support that idea. 5 a.m. It's too early. It's like till 7 a.m. or something. You know, you got to see the sun rise and then you're like, okay, maybe I can go home and take a shower for the next party, right? All right. Okay, let's see. Okay, so who can remind me what we've covered so far about regression? All of a sudden silent?
Well, I feel like first things first, you have to understand whether or not there's like a trend. You gotta set data. And like we have to see whether or not like there's a trend if we want to if we want to look at it in terms of regression.
Very good, very good. So Marco's like kind of implicitly almost bringing in the concept of correlation, which we're gonna go a little bit into deeper today. It's not a really complicated concept, except that we were looking, literally it's core and relation, right? It's two things, two variables, and correlation only we only use this term for 2 quantitative variables because correlation is a number that you can calculate, okay? You can't do that with qualitative variables. So correlation means a relationship in terms of how strong the relationship is. And we'll look at it, but there's directionality as well, because you can have a positive correlation and you can have a negative correlation, right? So you need to see if there's some kind of trend, meaning that there's some kind of relationship between the 2 variables we're dealing with, right? We're dealing with an X variable and we're dealing with a Y variable, right? Just one independent and one dependent variable. Just keep in mind, in the back of your mind, you don't have to know this for the final or anything, there could be multiple independent variables, right? And I gave an example, I think, like think about in fashion, if you were to predict the sales forecasting, if you want to do sales forecasting, number of sales in the past year maybe could be a good predictor, but things like how many days of storms you had, whatever, or how many days of snow you had could predict it, if it's something like snow gear related fashion items or whatever, right? All these different things can affect your sales, right? So there could be multiple X variables. However, in this particular unit, we're just going to deal with the simpler version. And you might remember simple linear regression, but we're just dealing with one X variable for now. But remember that you can obviously expand on that. And in most life situations, there will be a lot of variables that affect your dependent variable, which is also our prediction, right? The important thing about regression, if I say regression, you shout prediction, right? It has to be all about the prediction. We're trying to kind of foresee, we want to be able to predict the future, okay? And I was telling you, like in my other class and the upper level stats class, we do the, regression a lot in the context of machine learning. And the whole idea of machine learning or artificial intelligence is to make that prediction, right? That's because that's where the money is. Okay, so we are talking about kind of looking at 2 variables, seeing if there's some kind of trend, as Marco pointed out, and that kind of means that we can first look at correlation. And then if we have a high correlation, like a high correlation, meaning that the number is close to 1 or -1, we'll review that in a second. That means there's probably a very good, a high likelihood that X will be very good at predicting Y. Okay, so we kind of want to start there before we jump into a regression. You might remember we did the temperature versus gallons of ice cream sold, and we only looked at 3 data points. So initially we kind of thought it was a negative trend, but then we plotted more things and we realized actually it was a positive trend. So we need to make sure that we're kind of looking at the big picture and not like, you know, looking at only one thing, one side of the thing. Okay, all right. What else did we cover in regression, guys? Okay. Leslie is here too. Yes. Keep
we
going.
talked about how to interpret graphs and when they trend uphill and downhill.
Very
and
good.
then, you can determine whether or not it's strong or weak based on where the points lie and how like close together they're clustered.
Excellent, Ariana. Do you remember what that plot was called when we kind of plot all of these dots all over?
Is it just a scatter plot with like a trend line?
Yes, very good. So it's a scatter plot that we usually start with, and we plot all the data. And remember, it's kind of scattered all over, which is why we call it a scatter plot. And then, as Ariana and Marco pointed out, we want to find a trend, and we use the power of Google spreadsheets where we can just take the trend line and it will show you that trend line, which is our regression line. And remember, it's not deterministic. It's not deterministic, meaning that all the data points do not lie on the line, but it's all over the place. And the line is kind of like an average line, right? It's trying to estimate how it can represent all the data points, right? And depending on how scattered the data points are, your regression line will change a little bit. And we'll talk more about that as well. There's a particular number that we won't manually calculate, but Google spreadsheet will calculate for us, that will tell us how good of a prediction line it is and how strong that relationship is. Okay, so all in relation to correlation and this relation, this like strong and weak relationships. We're going to dig into that a little bit more. All right, Moranka says she's trying to get service. Okay, everybody's having service problems today, huh? What's going on? Let's see. Leslie's here. Sienna's here now. Okay, good. Okay. All right. Okay. So let's see. I think that covers most of it, guys, right? We used, we can, in the review sessions, we can kind of put all the Google spreadsheet equations we covered, but one of the equations we covered in regression is slope equals slope, and then we choose the y data and then comma x data, right? We use the intercept function. And then didn't we do Linus function yesterday, guys, or the other day on Wednesday? No, we did not do that with your class. Yes or no? That's where we need to start. Did we do rent the runway?
Not yet.
No, Professor, we did not.
We got introduced to it, right?
Yeah, I think I remember you said last class that we were gonna do that in today's class.
Okay, so that's where we'll start. Well, that will give us a good review as well. Okay, so let's all go to Blackboard. That's what it was. You guys, like your section and the other section keeps blending in because now like the other section has caught up with your speed. So I'm like, because you guys were always ahead of them and then they caught up. So now I'm getting all mixed up. All right, 308. Okay, so go to content and then go to regression. And remember, we took a look at the rent the runway setup, right? So the setup is all, we kind of familiar with it. So go to not the setup, but the link right below it. Let me just see what it's exactly called. Yeah, it's called Mod 6 Spreadsheet Assignment Rent the Runway. So not the setup, but the one underneath it. And go ahead and click on that.
Hi, Professor. It's Maranke. I just.
Oh, you made it. Is your internet okay now?
Yeah.
Okay, very good. All right, so we're going to, Maranke, we're going to Blackboard, content, regression, and then kind of if you scroll down, there's going to be Mod 6 spreadsheet rent the runway. Not the setup, but the one underneath setup. So go ahead and open that up. And if you make a copy, go ahead and make a copy in your drive and you're ready to do some scatter plotting and all of that. Type in a runway in the chat, guys. And then I will, maybe I can make a copy as well, and then I'll share my screen in a second, okay? Runway, runway, runway. Everybody who like asks me about my job, I don't know why this is like the only question they're really curious. They're like, so if you work at FIT, does that mean you get to go to the runway fashion show? And I'm like, no, that's not what that means at all. Why does everybody assume that? Isn't it like really a few selected people who can go to that? Like not even FIT people can go? They always want to know if I could go to the runway show. I'm like, probably never in my life I'll be able to go to that thing. Does it like there's certain people at FIT, you guys are like new here, so maybe you don't know. There's certain people who always get invited. Maybe the president of FIT gets invited.
I was in fashion design for the past years, and you can like sign up. Like actually anybody can sign up during like fashion week to like help out. I've been to a lot, and like
Or
you can
help out.
Yeah, but then there's also like they also like invite certain like FIT students. Like it's just like if you respond to the email fast enough. Like sometimes like runways need people to fill in. And they like bring people in from like FIT and stuff. So yeah.
Hey, look at that.
You just have to like sign up for like the emails. I think it's like from
But it's not like FIT receives an email. It's like the rent the runway. You have to like sign up or something and then they send you an email. Is that how it works?
So FIT sends you the email because somebody from like the runways or the company send FIT an email and then FIT sends it out. But you have to sign up through emails, I think through I forgot. Oh my God. I'll remember and I'll put it in the chat because I completely forgot. It's like
Oh, okay.
Yeah.
Well, that's a new piece of information. I didn't know that. Oh, okay. I thought that was like a strictly invitation only kind of thing. So you can go volunteer. That might be fun. I can finally answer the question. I'm like, I was not invited, but I volunteered with my FIT status. All right. Okay, so if you have that open, what we're going to do is we're going to follow the A, B, C, D, and this is just all the stuff that we've done, so it shouldn't be too complicated, okay? So I'm going to share my screen, and then I'll move this over. Wait, what's happening? Oh, didn't move. Make sure my chat is open. So chat me too if you have questions. All right, so what we're gonna do is we're gonna start making a scatter plot, okay? So what you wanna do is you wanna highlight the data, okay? Right, what you could do is that what I like to do is I click on the first cell and then I hold shift and go to the side, right? And then I think you can do, what was it? Like Command Shift D. Oh, that's not what it was. No, Command Shift bottom arrow, down arrow, I mean, and that should select everything that's an active cell. So for Mac users, Command Shift down arrow, and I think for PC, it's Control Shift down arrow. And then it should select all the active cells for you. You know, it gets kind of like selected as blue. And then we're gonna go to Insert, and then we're gonna go to Chart. All right, so it might take a second. All right, so by default, because Google Spreadsheet is quite smart, it should automatically choose a scatter plot for you. If that's not the case, you are going to see a chart editor on the right side. And in setup, there's the first thing that pops up is chart type, and there's a drop-down menu. Make sure you scroll down and choose the scatter, okay? But automatically, it should choose the right chart for you. So you should see something like this. You guys got that?
Again.
Okay. So you might notice when you look at it, it's like, oh, these like kind of dots are actually cut off here, right? So that's not really good. And I'm actually not sure why Google is not smart enough to detect that, but we can fix that, okay? So instead of the setup thing, kind of like on the right side, you'll see a customize kind of thing. And then you're gonna see vertical axis, right? We need a little bit more room on the vertical side. So go open up the vertical axis so it expands, and then scroll down, and you can choose a maximum value here, right? So it seems like it's getting cut off at 125. So maybe choose something like 150 or something, and it should automatically adjust it right away, okay? So now I see that I can see all of the points and nothing's cut off. So my scatter plot is complete, okay? All right, so I'm gonna X out of this chart editor for a second, and I'm gonna read the B. All right, so you might remember from the setup from last class that we were trying to identify what we're calling here a little bit unusual. Do you guys remember what those points were? Or what those data points were? When you look at the scatter plot, what's a little bit kind of weird and sticks out?
The clusters on the bottom.
Very good, right? These clusters on the bottom. Very good, Taylor. So it's like, it's a little weird because the retail price, like let's say this is like, I don't know, 20, 30, 70, 100, whatever. And then it's 200. Obviously, it's quite a range, but we can see that the rental price is all the same. And you probably won't expect that, just anecdotally, if you were like a company owner too, you wouldn't, something that's more expensive in retail price, you probably want to rent it at a higher price, right? So something's going on here. So either the input was the data is corrupted and something's not going right, or this was on purpose and it was a promotion, but we don't know what it is. And for now, it might be, it could considered outliers. So for now, we don't really like it. So let's try to take that out for now, because when we do this prediction and correlation or whatever we're doing, we want to make sure we don't have all this kind of weird data that's skewing the results that we're going to do. Okay, so for now, we want to get rid of this. And from this particular view, we know that anything, if you were to roughly kind of see the retail price, anything below maybe 300, that's probably a good guess, or a rental price that's kind of lower than 40, maybe at 30, those are all the points that we might want to exclude, right? So how are you going to find those things? You might see the first one that's 30, so that's probably it. The fourth one is like 32, but you know, and then there's another one here. So you might find it, but that's kind of like not an efficient way of doing it, right? So what we're going to do is we're going to make sure that our data is in ascending order or descending order, okay? So I'm gonna go ahead and like click on column A. And what you need to do is, I think it was data. I think it was data, guys, okay? So if you click on that, The first two options are those options I said. It's ascending order or descending order. So even though it says A to Z and Z to A, this also applies to numbers. So this is, you can kind of think of this as 0 to a high number, and then Z to A is like the highest number to the lowest number, okay? So I'm gonna go ahead and click on the second one, because I wanna keep the ones I don't want, I'm gonna keep them on the bottom, okay? So if you sort this, usually spreadsheet is smart enough to also switch the B column that follows along with the A column, the B column, the B cell that's associated with that A cell. So go ahead and do that. And we can tell if this like changes too, that it did do that. So go ahead and choose that second one. And then you'll see that retail, I guess the highest retail price item, clothing items $8.50. So that kind of aligns with what we see on the graph. And the rental price for that is $125. So if we go to the Y, that seems to be, it could be like $125 roughly. And then it goes down, descending order. And now you can see all the 30 stuff is all the way on the bottom, right? And that's kind of what it looks like these things are, okay? So you can just keep this here. What I like to do is maybe like I cut it, you know, and then maybe I put it like a little bit below. So it's somewhere else. It doesn't have to, you can leave it there. I just kind of want to put some space in there so I show that it's like a little bit separate, and I want to maybe call these the unusual data points. So what I did was kind of like earlier, I just selected the cell, hold on my shift key, and I, you know, selected what that was, and then I cut it and pasted it somewhere else. Okay, so that's what I did. You don't have to, because what I'm gonna do now is without those unusual data. So starting from line 25, I'm gonna hold shift and select again, and I'm going to create a new, scatter plot so that I don't have to include these unusual ones. So I'm gonna go back to insert.
Professor.
Yeah.
Sorry. Going back a little bit, when you first click on a whole column and you press data, what do you do when you press data?
So if I wanna select everything, so I click on this, I hold the shift key, and I just press the down button because I'm going downwards, right? Earlier, what I did was I started here. So I pressed the shift key, and then I selected the up arrow. I'm doing up, and then I go to the side. So I now do the side arrow, and then it selects that.
No, I'm saying when you selected the whole column A and you went into data, what did you click on when you went into the data?
I
the
see what you're
data
saying.
part?
So I clicked on A, and then I clicked on data, and I selected the second one that says sort sheet by column A. And then it says Z to A, which this means kind of like higher number to the lowest number is what it means in terms of numbers. If it's letters, it's from Z to A.
Okay, thank you.
Yeah, and then accordingly, the B column, the B cells that are associated with those will also switch automatically. This is kind of like a smart tool. Okay, and so then I'm going to select, again, the data points that I want in my new scatter plot. So I'm going to select that, and then I go insert, and I go to chart again. And it's kind of just going to go on top of the original chart, and that's fine. You can keep both of them. You can delete the previous one, whatever you feel like, okay? Note that, again, these top data points are, again, kind of cut off. So go back to customize. And let's go back to vertical axis. I'm not really sure why it's doing that. It really should detect it automatically, but we'll switch the maximum value to 150 again. And then no big deal, right? So then you can see everything. Okay. So you might have noticed this happened to you too, but I think these ABCD things were associated with these cells or some kind of connection there, which I should have gotten rid of. So your instructions might be all over the spreadsheet. That's fine. Just make sure that you can find it somewhere. But anyway, so we did B, and I think somehow C is underneath this thing. But C probably just says, let's get the slope and intercept, right? Run regression analysis using slope and intercept using only the good data, right? So we have all of this. And so we want to do regression. Okay, so what we're gonna do is kind of like select a cell anywhere. I'm gonna select a few cells. And what I'm gonna do is, you might remember this from what we did earlier, there might be some weird automatic settings that are done, just like, that's why A, B, C, D, these instructions got all over the place. I don't want any of that. So I'm gonna go to, I think it was format. Yeah, and then go to number. And then instead of automatic, just go click on plain text. What that means is if there's anything automatically is trying to calculate or do or whatever, like ignore that and just kind of think of this as a plain text cell. Okay, so nothing gets carried over. You might remember that we would calculate a number and then you hit enter and everything got rounded up to 1. That happened because some kind of setting was associated with those cells. So make sure it's just kind of like a plain text. Okay, so here I'm going to do equal, remember, slope, and open and close. Okay, so I'm going to do slope in here, and remember, inside the slope, so inside the parentheses, we are going to put the y information first, and then comma, and then the x information. Okay, so I'm going to go, oh, oops, I should not have clicked that. Once you click something, it's going to put it in there. So I'm going to go, and the y is rental, so it's the B column. So I'm going to select it, and then I'm going to drag it down, and I want it all the way to row 25, right? So that's, and then you can see automatically it listed that inside the parentheses. I'm going to do comma, and then I'm going to go ahead and start for the X values, which is retail, and I'm going to drag it down all the way up to 345. And you will see inside the equation that it selected the right cells. And then once that's done, so you have the Y values in there, comma, the X values, then you can hit enter and make sure the parentheses is actually closed. Okay, so I'll hit enter, and then here we got the slope. Okay, so I can write in, maybe I can do this. Just do here, I can do M and it's slope, right? Just to kind of show that what that is, right? And then here I'll do B, which is going to be the Y intercept, right? Okay, so here I'm going to do equal again, if you guys remember, and it's literally just intercept, right? You can click on the one and it'll automatically fill it for you. I like to close the parentheses right away, but you don't have to, but it just kind of reminds me that I won't forget. Intercept is the same thing. You're going to choose the Y first and then drag it down for all the Y values. And so that's selected. Again, you do the comma, and then you do the X values up to 345. And for me, it's already closed because I wrote that in. But if it's not, make sure you then close the parentheses and then hit enter. Okay, so now I have an M slope and a Y intercept. So we could, the equation, we could write out the equation, and we can do Y equals 0.169-ish times X minus 11.035, right? And I can expand this a little bit, right? And if you want to be a little bit more technical, you could do the regression equation, which is basically the same thing. But if you want to be a little bit more technical, remember it's technically called Y hat. And then we kind of like to flip the order of these things in when we traditionally write out the regression equation. So we can do negative 11.035 plus 0.169 times X. But really, this is acceptable and this is also acceptable for our purposes, okay? So this is just kind of like more of the really exact way of writing it, kind of like the way traditional statisticians would like to write it. And this is just kind of, how just in general you might write it, okay? But it's the same thing, right? It's the same thing, mx plus b, or what we call beta plus mx, right? But same thing. And that's going to be that trend line that that Google, we're going to use Google to draw for us, okay? So let's go ahead and make sure this relevant scatter plot is selected, right? There was two. make sure that you're selecting the one that does not include the unusual data points, okay? So select that one. If you double click on it, then that menu, the chart editor, will pop up on the right. Okay, so double click on it. Now let's see if I remember this. I think it was inside customize, go to series. Go to series, and if you scroll down, there is a place where you can tick a box for trend line. So go ahead and do that, and then you'll see that nice trend line go through. And as we have been seeing, right, the scatter plot, like the dots are all over, but the trend line is kind of somewhere in the middle, and that's the prediction line, right? The data points don't necessarily lie on top of that prediction line. So if we were, for example, we don't have a data point for that, but let's pretend something like $6.50, a retail price of a clothing item was $6.50. We don't have an actual item that is actually $6.50, but if we were to get something like for $6.50, well, what would be the prediction for how much you can rent it for a day? Well, you plug it in and you'll get something like maybe $100, right? So this is kind of like the predictions you can make based on the existing data that you're using to create this regression line. Okay, up to here, are we good? Did we get the regression line?
Actually, I had a question. So when I punched in the slope and intercept, I got something completely different.
Okay. Make sure, I think this happened to my other class, you're not including those unusual data points. So I only included kind of like what we're calling the usual data points and not any of the outliers. So that could have been it.
I made sure of that. Like anything below A25 and B25 we're not using, right?
Correct.
Yeah. I did that. But I still got
You did that?
something.
Okay.
Yeah.
All right. So can you, let me just, can you go ahead and share your screen so we can take a look? Anybody else not get 0.1689 for their slope? Anybody else as well?
Me, I got a different number.
You got a different number too? Okay, so let's start with Marco.
For your when you put it the regression equation, you put 0.159. Is that it's when
I got 0.1689, so I just kind of cut it off and I did 0.169.
okay.
Yeah, did you get 0.159?
No. I think that's what you wrote by like accident.
Oh, did I? Oh, I did write that. You're right. Okay, that's a typo. Sorry.
Right.
It looks like you got the right number. There's 0.1689.
The one below that though is what I'm kind of confused on.
Oh, okay. So let's see. Intercept B2 to B25 and A to the A25. Intercept. Oh, I wonder if some weird automatic setting is happening. So go to format, and go to number and go to plain text. Yeah, click that. And then let's right next to that cell, or just delete that cell and do it one more time in that. Okay. Yeah, equal, intercept, good. And then click the B, right? The B2 all the way to B25, colon, yep, B25, comma, A2, colon to A25, close. Oh. Okay, scroll down. Let me see what A25. Oh, scroll down too. Let's see. That is a little weird. So mine is. Oh, I guess you're just two places. So why is that happening to you? Okay, go back up. It's got the right slope, but not the right intercept.
I didn't get the right slope either. Like I got like, I forget which number I got, but like I just copied the one from your screen because like I didn't get the right slope.
Oh, you didn't get the right slope either. Okay, so something's definitely going on in your cells, I think. Okay, so just go to like the K column
Yeah.
Yeah, and then select like a few cells down. Yeah, and then go to format, and then number, and then plain text. And let's try that one more time. Okay, so now do equal.
And
Yeah, on
this,
the top. Yep, equal slope. And then instead of typing it in, yeah, click on that, and then go to, yeah, click on B2. Yeah, and then drag it all the way down. Yep, there you go, all the way to the 25th line. Yep, and then do comma, and then do the same thing and drag it all the way down. And now do enter, or close the parentheses and then do enter. So let's see what happened. Oh, what is going on with your spreadsheet?
I don't know.
Is this happening to anybody else? Your spreadsheet is.
I just didn't get the same numbers as like everybody else.
Huh. Okay. Can Marco and Jada, can you both share your spreadsheet with me, and I'll take a look at another time.
Okay.
I wonder if it's like some weird setting that's going on. Yeah. Well, that's a little weird.
Yeah. Wait, I could still wait.
Yeah, send it. And then Jada, do the same thing what Marco did, so I can take a look. Yeah.
Like the linear regression graph, like if I just do everything here and then like, because we're like, for the graph, we don't.
Wait. Marco, I found something weird in your data set. Maybe that's what's happening. Scroll up.
Yeah.
So you see that weird number on line 11? You have a rental that's 850. That cannot be correct because the rental only goes up to 120 something. So something's happening in your data.
Over here. Wait, damn it.
Yeah, so that number in my data set is 70. Okay, so something happened. I wonder if that's what happened to you too, Jada. Something like happened and maybe some numbers got mixed up. Yeah. So what you could do is basically just go back to Blackboard and copy the original one again, because I don't know how many cells have been affected. But yeah, you can try that again. But I wonder, yeah, that was weird. Because remember, we made it into descending order. So that like popped out as a weird thing. Okay, so it's closer. So I think maybe there's one more cell that's a little bit weird. And we won't be able to like find it maybe immediately. But it seemed like somehow some numbers got mixed up a little bit. And that's why you're not getting the exact number. I think that's what it was, okay?
I think I kind of got the idea though, I think.
Yeah. As long as you know how to, do equal slope and equal intercept. And remember in the final, I'm not going to give you a spreadsheet. So if you just open up a new spreadsheet, there's not going to be any settings or anything that carried over from another thing. So you shouldn't have any trouble with that, okay? And also remember, guys, you guys are going to get like 2 attempts per question. So if you somehow didn't get it right the first time, you'll have another attempt to get it right, okay? All right. So the regression equation should be y hat equals, negative 11.035 plus 0.169 times x, okay? What else? What does D say, guys? Is that the last thing it asks us to do? Remove data values both for x and you should put that in the, that was B. And D said, oh, we're going to do some predictions, guys. So now we want to do some predictions, okay? So this is the last thing that we're going to do. And we're going to do it for 200, 400, and 900, okay? So let me go share my screen. All right, so you should also already know how to do this, right? We were anchoring and just applying these numbers into the X value, right? Okay, so I'm going to go ahead and just type in 200 here, and then 400 here, and then was it 900, guys? And you can put in some other different numbers if you want to try out. But basically, we're gonna just do the equation, right? We're gonna do equal, and then we're going to use, and you can, oops, I'll do equal, and I'm just gonna follow this equation order, okay? So I'm gonna do the M, and then remember, I'm gonna do multiply by this cell. So that's gonna input 200 for me, right? And then I'm gonna do minus this number right here, which is the y-intercept, right? So I'm following y equals mx plus b. However, remember that the m is always going to be the same and the y-intercept is always going to be the same, right? So remember, I corrected this last time. So you want to anchor those. You anchor them by using a $sign in front of the letter and then another $sign in front of the number. So that's for the m. And also I want to anchor the y-intercept. So I want to put a $sign right in front of the j and then right in front of the 5, at least for me, right? I don't know if you actually chose the j column, right? And so then once the m, the slope, and the y-intercept is anchored, meaning that it will never change, I hit enter, and then I can go back to this cell. And remember, there's that kind of square at the bottom right. I'm gonna put my cursor on top of there and I can scroll it down and it would apply the different x's, the 400 and 900 into that, but it will keep the m and the b the same. And then you can do that and let it go, and then you'll immediately have your results there, right? So this I can name predictions. And then this column will be, well, this column will be the prediction, right? This is the x and this is the y. These are the x's and those are the y's. So if I have a clothing item that the retail price was $200, I might rent it for about $45 a day. And then if it's $400, I might go up to about $79 a day. And then if it was a $900 item, which is quite an expensive item, then I would rent it for about $163 a day. Okay? So up to this point.
I got like different numbers.
Yeah,
That's
so
weird to me too. Okay. Okay. So
Do we have to minus the y-intercept?
Yes. Yeah. Well, you don't like you minus it in that. I think I did that correctly. Oh, guys. Oh, I'm so sorry. This should be a plus, right? Right? Because this number is a minus, right? When the minus and the plus meets, it becomes a minus. So I should not ever use the minus sign. I should always use the plus sign, right? So I need to fix that. And then I need to apply it to the rest.
I also have another question. So if this was like say they gave us the entire data set, and this is like a question on the test, like what like predict the rental price for an item that's like $200, would it be 30 because of like
rounding?
Or no, because like the other ones are 30. The ones that are like anything that's below $300 is like 30.
That's a great question. What I would ask in the question, it will be specific, like round it up to, you know, whatever. So then you'll just follow those instructions. I might say 1 decimal point. I might round it to the next whole number. And in that case, that would be 23, right? Because it's 22.7.
Right. But I'm talking about like in this like data set, because like there's like a cluster, like a line cluster.
Oh, the things on that are $30, that the unusual points. Yeah, if that happens, is what do we include it or not include it? Is that the question?
Yeah, like, or I mean, like, would the answer be like 23 or would the answer be 30? Because like, well, I guess like it's not following the regression line, but it's following like the data.
Okay, so I think you're getting a little bit confused. So the data points are the raw data points, and nothing about that changes, right? And then once you plug in a number and get a prediction, that's just, you take that as face value. You don't change those numbers, right? So even though there's no numbers in the raw data set that says like $90.80, even though that doesn't occur, but in your prediction that does, that's okay. You don't like change it to fit into this kind of category or anything like that. The raw data is raw data. You don't touch that. You only use it to calculate the slope and intercept. And then the prediction is when you plugged it in, what you get, and you don't change that either, except maybe I tell you to round it up or something like that. Yeah. So just because, you know, in one area you see like whole numbers and then here you see decimal numbers, that doesn't necessarily mean that you need to like change things unless in the instruction I tell you to do something like that. But even if you were, if it's 20 to 22.74, if I say round it up to a whole number, then it will be 23.
Professor.
Yep.
I just want to go over why you put plus 11 instead of minus 11.
Great question. So the default equation, guys, the default equation is mx plus b, right? The b can be a positive number and the b can be a negative number, right? The b is whatever you get, but the default equation is plus the b, because when it's a plus number, the plus plus becomes a plus. When b is a negative, the plus and negative becomes a negative. But if you put in a negative there, which is not the default equation, then the negative and negative will become a plus. And that's not actually the number we're looking for. So the default is mx plus b. And then the b is whatever number you get, whether that's a plus or a minus. You guys remember that from high school? So it's kind of like, say that again?
So it'll always be plus b?
Yes. Yes, it will always be plus b, and the b will be whatever number you get, whether that's a plus or a minus.
Professor?
Yep.
Okay, so I redid my entire spreadsheet because mine was messed up, and I'm like a little like behind.
Okay.
When I did the slope and the intercept, it wasn't the same exact number that you got, but it was closer than what I originally had.
Okay. Did you share that new one with me?
No, I shared the old one. Share this one too.
Yeah, go ahead and share that one. So I'll go into that one. Okay. Everybody else, you got the prediction numbers? All right. If you got the prediction numbers, type in prediction in the chat for me, okay? And then if you are done with that, you will share that spreadsheet with me right now, okay? So that's your in-class participation. So share that with me, because you won't submit it, you'll just share it with me, and that's kind of like submitting today, okay? So go ahead and do that. And then before it all trickles in, I'll go.
Wait, so Professor, we only have to share the spreadsheet?
Correct. You only have to share the spreadsheet, this particular one, Rent the Runway. Okay, and then before it all trickles in, I'll try to get Jada's first. Oh, all right. So let's go ahead and share, everybody share that one. And then when you are done, let's all go to, where's my other tab? Now we're gonna read a little bit about correlation. And then from that, we are going to learn about R squared, and that will be it for today, okay? It's a correlation you already know. We're just gonna go a little bit deeper into it just to kind of get a better sense of what it means and the definition. And then from that, because it's related, we'll talk about R squared, and that will be it, okay? If I can ever find this tab.
Wait, Professor, I have a question.
Yes.
The R squared value, squared value, is that the same as the chi-squared value, or are those two different things? Because
Those are two different things. Those are two different things, yeah. So we won't cover chi-square in this class, but we will be covering R squared today. Yeah. And R squared is related to regression. Chi-square is a completely different thing. It's a completely different statistical tool that you use in a different situation, but it's a good one. I don't think in your lifetime you will actually have to do chi-squares, but maybe. Okay, so in the chat, I have shared a Google Doc. I'll make this available on Blackboard if it's not already, but go ahead and open that up. And that's a little bit in detail. We won't read the whole thing. I'm just gonna point out a few things, but this is about correlation. If you have this open, make sure you make a copy in your drive. And if you have it open and made a copy, then type in correlation in the chat, okay? And then in the meantime, I got Jada's open. Oh no, maybe that's mine. Oh, Jada, okay. It looks like Jada, you're missing one cell. So it was supposed to be till cell 25. So what you did was you separated you added one more in the unusual, but you need that last one. So it's now in your row 31. So 345 and 45, just move that over to the top place where you have the quote unquote usual data, and then select all of that and calculate the slope and intercept, and then you'll have the right numbers. That's why it's like very close, but not quite there. Does that make sense?
Hey, Professor.
Yeah, I'll highlight it for you.
Thank you. Thank you. I'm gonna fix it now.
Yeah, okay. Yes, Marco, go ahead.
Okay, so I'm gonna just share my screen real quick.
Sure, sure.
Hang on. These are the numbers that I got using the numbers that aren't exactly correct, but I used like the J5 times the slope. Wait. Yeah, I used the X times the slope plus the intercept. That's the intercept that I got. So is it okay if I just have this here for now? And then
Yeah,
for some reason I got an error here.
Oh, because you have 2 equal signs instead of 1 equal sign.
Oh, my bad. Okay.
Yeah. So the numbers are off, but you get the concept, like how you would do it, right? So as long as that's understood, then that's fine. Yeah.
Yeah. All right. Cool.
Absolutely. Yep. Yeah, that's I mean, that's a good point that Mark was making, guys, right? Even if like your numbers are not exact at this particular moment or any in-class activity, as long as you understand the kind of like the principles, right? That I need to use the slope function and I need to select the y first, comma, the x things, and then you do that the same for intercept. As long as you understand that, and for prediction, I'm using that equation and anchoring the m and the b, and then only the x is changing. As long as you understand that, that's all you really need, right? Okay. All right, so let's dig into correlation a little bit more. There's nothing complicated or anything or really that much more that we need to know. But correlation, remember, is something that you might want to look at before you start doing a regression, right? We want to first kind of see that there is quite a bit of a close relationship between these two variables before we just dive into making a regression, because we don't want to make the wrong inference, right? We don't want to make the wrong conclusions. Okay, I send it to you guys and I have seemed to lost it. Oh, here we go, correlation. Okay, so let's just look at a few definitions here. So this is from a colleague who made this. So I'm just gonna kind of walk through a few things. Okay, share screen. All right, correlation, okay? So, can we predict one variable from another, right? So that's kind of like eventually where we're going, and correlation is a very, very good measurement that can take us to that conclusion, okay? So, things that you might be able to ask is like, can we use a father's height to predict the height of a son? Can we use a shoe size to predict a person's weight? Can we use a student's GPA to predict their income during their first job? Oh, interesting. I don't know if there's a relationship there. Maybe there is. I don't know. I guess there could be. Can we use the temperature in New York City to predict the temperature in Boston? Can we use the temperature in New York City to predict the temperature in LA? That seems a little bit less likely. Or maybe there's a negative relationship, so maybe. Can we use the temperature in New York City to predict the crime rate in New York City, right? Maybe there's like less crimes when it's cold. I don't know. So anyways, we can ask all these kind of questions, and some might seem pretty obvious and some might seem a little bit ridiculous, but that's just kind of in our head, right? We need to actually be able to tell if this is a good question to ask, and that is something that we can, a correlation is something that can help us do that, right? Okay, so this green paragraph, Ariana, please.
If the correlation is strong, we expect our prediction to be accurate and reliable. If the correlation is weak, we expect our prediction to be less accurate and less reliable.
Very good, right? We want it to be strong, and I'll let you know what that means in a second in terms of numbers. We then we can be relatively confident to be like, oh, okay, so the X will actually be a very good predictor for Y, right? And if it's not, then we're going to be a little bit less confident that there is kind of a strong relationship in terms of making a prediction, okay? All right, to say how strong, Leslie, please.
To say how strong the relationship is we find the correlation coefficient. The notation for it is R, and it has a formula that looks like this.
Right, so it's a pretty complicated formula that you see down here. Do not worry about it. We're not gonna do this by hand. In old statistics courses, you used to do it by hand, but all you need to know that we use this notation like small r to represent correlation, right? And then remember from the slides last time, the whole name is Pearson's correlation coefficient. You would know this in physics and math and all science and stuff like that. Usually the person who comes up with this idea in the long time, like way before our time, usually that's how things are named. So Mr. Pearson was the person who found this correlation, right? So it's Pearson correlation coefficient. All you really need to know is that it's a correlation, and we use the symbol R for that, okay? And if you want to know a little bit more of what it actually, what it involves to calculate the R, this is an explanation for it. You don't really need to go into it very deeply, but if you kind of are one of those curious ones and see how it's calculated, you'll be able to tell that. But basically, it's multiplying Z values of the X data and then multiplying that to the Z values of the Y data, okay? All right, so if we were to try to calculate the correlation coefficient, all we need to do is just plug it into spreadsheet, and I think it's like equal CORELL or something like that. We can like, you know, start typing it in, and obviously the drop-down menu will show you what it exactly is, okay? So if we were to like put a scatter, make a scatter plot with these data points, something like this will be shown, okay? And it's scattered a little bit, and maybe we can draw a trend line through it. Maybe it's a little bit harder, but you know, there's, you know, options, right? So we know that this is called a scatter plot. There's not many data points. We have 6 of them to be exact, but that doesn't mean we can't do a regression line. But one of the things that we want to maybe consider before that is to look at the correlation, okay? Correlation coefficient, this is important to know, and I included questions about this in Lumen, so do know this. Correlation can be between +1 to -1, okay? That's how we calculate the correlation. And it's gonna be between -1 and 1. And I briefly mentioned this last time, but -1 means a perfectly negative correlation, and 1 means a perfect positive correlation, okay? So 1 and -1 is less likely to be seen, but if it's 1, basically all the data points will actually lie on top of the line, right? It's a deterministic relationship you'll see, and then you'll have a perfect positive correlation of 1, and -1 is basically the same thing, except it's just in the negative direction, okay? So anything in between. So then the ranges you'll be considering is between +1 and 0, and then -1 and 0, right? Depending on whether it's positive or negative. 0 means there's absolutely no relationship at all, right? Which is also very unlikely to happen, okay? So some examples will be these kind of things. So these, the top one here is a positive relation, as you can probably tell, but it's more scattered about, as opposed to something like this one right below it, right? This is a positive one and this is a negative one, and they both seem to have a trend, that trend line you can probably like draw in your head, but you can already immediately tell the bottom one, if you were to draw a line through it, the data points are tightly closer to the average line, the regression line, right? So this is going to be a very high correlation. So something like maybe -0.97 or -0.99, okay? This is a little bit more scattered, but it still has a pretty high trend that you can see a positive one. So I would go for maybe 0.53, maybe even higher or something. But anyways, it doesn't really, you don't have to have the capability of guessing it correctly. But if you want to kind of test yourself and get used to it, you can use this link and try it out. I wouldn't go as far as to call this a game, but you know, you can kind of like train yourself to kind of recognize it if you want to, but you don't have to. You don't have to, okay? All right. So let's see. I think there's answers here. If you want to try to take a guess at what these are, and then we can kind of see how well we do. What would you guys say the correlation would be for this one? So it's, first of all, you need to know that it's positive here, right? and then that it's, if you were to draw a line kind of in the middle, still there's a lot of deviations, meaning that the data points could be quite, there's some that are quite far away from that middle line that you could potentially draw. So, oh, this is easy, right? Because there's only one positive number. So this is for sure 0.53, right? This is a negative direction. So this one you have to choose. So would you go with negative 0.33, 0.97, or 0.99? Which one would you guys go for?
Negative 0.33.
Right? It doesn't seem like it would, it's scattered pretty all over the place. And compared to, like, say this one right here, which is very neatly, almost like in a straight line, that is more scattered. So that's probably definitely negative 0.33. And this is probably, if I'm having these two right next to each other, I bet this is negative 0.97 and this is negative 0.99, right? Because even less is scattered about than this one, right? So that's kind of how you would determine the answers. I'm sure. Does it actually give you the answers? Let's see. Okay, let's get to explaining. Oh, it does tell you. I think this is, it just says weak, weak, moderate, or very strong and stuff like that. That's a very weird way of, I don't understand how the answers are. What? A, B, C. Oh, A, B, C. Oh, I see. Okay. And then the actual answers are right here. So very good. I see. Okay, so that's really all you need to know about correlation, that it's between -1 and 1. And if it's perfect, a perfect positive one, it's 1. If it's a perfect negative one, it's -1. And 0 means that's basically there's no relationship whatsoever. All these extreme cases are going to be very, very hard to find usually. Okay, so that's all you need to know about correlation. And then let's quickly go to Mathplosion, and I will send the link for the right chapter. But guess what, guys? We are on the last chapter. Oh, we didn't do the linist. Oh, we got to do that too. Ooh. Okay, let's do R-squared really quick, and then we can do the linist later. Okay. All right, so we're gonna do the last chapter as of now. I'm gonna make more chapters over the winter break. Where is my chat box? Oops. Okay, go here. But if you also have it bookmarked like I do, you can just like click on it and scroll all the way down to the R-squared chapter. Okay. Oh, I actually do think I have a nice video that introduces R-squared for you. Okay, so I think I liked it from, I think I included in the Blackboard, and you don't need to see the whole thing, but we're just gonna see it from like minute 3 or something like that. Okay, here we go. Okay, so I'll show you a little bit that introduces R-squared, but as you might be able to see already, it is literally R-squared, like that small r you've seen from correlation, and it's the squared of that. That's how it's related to correlation, okay? So that's all it is. Once you get the number for a correlation, you're gonna square that, and that's what R-squared is. But let's try to see what that means. What is it telling us when we talk about this R-squared metric, okay?
The slope of a regression line predicts the change in y when x increases by 1 unit. So in our example, the slope is equal to 0.311. Therefore, we say that as study time increases by 1 hour, we predict a student's GPA to increase by 0.311.
Obviously, this is just kind of an example from what they were doing in the prior part of the YouTube video, right? So they were saying that maybe the number of study hours that student studies will be a good indicator to predict the GPA, right? And then this is the y hat. You see that, right? Y hat, that's the regression equation they came up with. Okay.
We can actually use this equation to predict a value of y using any value of x. For example, based on this data, if we have a student who studies for 6.5 hours a week, we can predict this student's GPA. All we do is plug the value 6.5 into the formula, and we get a y hat of 3.47. This means that for someone who studies for 6.5 hours a week, we predict their GPA to be equal to 3.47. The last thing I want to talk about is r squared. R squared is literally equal to r squared, or r times r. Do not get confused between r and r squared. R has values between -1 and +1, whereas r squared only has values between 0 and 1. Correlation measures the linear relationship between two quantitative variables with respect to direction and strength. On the other hand, r squared is a measure of how close each data point fits to the regression line. So in fact, r squared tells us how well the regression line predicts actual values. Let me show you what I mean by this. Consider this scatter plot. Each blue dot represents an actual value, and from this data, we can make a regression line. Now, any point that falls on the regression line corresponds to a predicted value. So in general, an r squared that is close to 1 tells us that the predicted values and the actual values are close together. In contrast, a low value of r squared tells us that the regression line doesn't fit the data that well, and we can clearly see a large amount of distance between the actual values and the predicted values. And if r squared is exactly equal to 1, this means that we can predict the value of y for any given value of x. Note that r squared also tells us the percentage of variation in y that is accounted for by its regression on x. So in our previous example, we had calculated r to be 0.94. The r squared value would be equal to r times r, or 0.88. So this tells us that 88% of the variation in GPA is accounted for by its regression on study time.
Okay, so that last part is probably a little more difficult to understand, but all you really need to know is that as it was showing, I think the video was doing a good job of showing how far away each data point is from that regression line, right? So if there's less of a distance, so there's not a lot of deviation, that means the r squared would go up. And then if there's a lot of really big distances from each of the data points, then the r squared will go down. So typically, in most cases that we will encounter, you want the r squared to be very high. So it's an assessment technique, if you will, to kind of assess and evaluate how good our regression line is. The higher the r squared, the better the prediction line is. So if you go to Mathplosion, we have some visuals that really represents this really, really well, okay? So I will share my screen. And I think visually this makes the most sense and it's easiest to see. So obviously because it's squared, that's why there's gonna be no negative numbers, right? R, the correlation is between -1 and 1. So there's negative numbers, but once you square that number, as you already know, there cannot be any negative number. So that's why r squared is always between 0 and 1, okay? Again, these extreme numbers are rare, but theoretically speaking, if you were to kind of draw it out, r squared of 0 means that everything is scattered all over the place. And if it's r squared is equal to 1, there's no scatter at all. So this is the examples that you can see. This is r squared equaling 1, right? So every single data point is actually on top of the prediction line. So this is just basically a regular y equals mx plus b, right? And then if r squared is very high, so very close to 1, then you'll see only a little bit of scatter from the line that you could probably draw through this, okay? R squared equals 0.99, kind of like we were seeing in the correlation mini lecture in the Google Doc as well, right? If the r squared goes down, a little bit more down, 0.95, there's a little bit more scatter compared to this one right here, right? If it goes down more, a little bit more scatter, right? So the deviation is increasing as the r squared goes down. Again, we want to have a high r squared to have a very, very nice prediction line. And then more and more it goes down, the more and more scattered it's going to be. So this is about 0.8. That's about 0.7 in terms of r squared. And then you see 0.6, 0.5. And these are really, really, really small r squared, right? If anything, it's closer to 0 than it is to 1. And then you see that it's just scattered kind of all around, right? So if you were to draw a line, it's not necessarily kind of like this way, right? It's going to be like almost kind of going like horizontally, right? Because those things are here and they're here, it's all over the place. So it's a very, very low R squared, and it's gonna be hard to find that trend line, okay? So it's difficult to see a trend, okay? This last part, this is basically the last part currently in Mathplosion, is what the video was saying earlier about this explained variation. It's okay if it doesn't kind of come to you right away. This is just kind of like an additional explanation. This is kind of like the technical statistical definition of what R squared is, right? So R squared is sometimes called explained variation. And basically what it means is that, you know, you might ask, why is there so much variation? Why is this data point all the way here? And why is this here? And why is this here? Why is it that when we draw this prediction line, or like this way, I guess, for this particular case, why is it that there's like such wide distances? And maybe for this one, why is there less of a distance, right? If you can explain it, that's really good. And R square is that value that is able to explain the variation, okay? So if you have something like 0.9 as your R square, that means about 90% of that kind of variation, that deviation, you can kind of explain it with what already exists. You can explain that variation in Y by the available X data points. So that's explainable, and that's covering 90% of data. But the 10% of the time, we don't really know what happened. That's kind of like a little bit of a mystery. Remember when we were doing the temperature versus gallons of ice cream? And you would normally think when the temperature increases, there are more ice cream that should be sold. But that's not always going to be the case in real life, right? Sometimes even though it's hotter today, we sold less ice cream than yesterday. So those are kind of like the anomalies and things that we cannot explain, but R squared is trying to explain as much of that variation as possible. And that's kind of like a numeric value that does that job, explaining that variation. But there's always going to be a little bit of kind of that part that we can't really explain mathematically. And that's the remaining part out of the total of 1, okay? Again, we won't be using this kind of explained variation wording as much, except that we are going to just know that R squared is a very good metric to kind of see how good our prediction line is, how scattered are the data points, how they are, how deviated they are from the prediction line. So that's kind of all you really need to know about R squared, okay? Any questions of that, of correlation, and then that squaring that and making talking about R squared? Any questions regarding kind of like the big concepts of those two things? No? Okay. So what we're gonna do, just the last thing, because I think I didn't do this with your class, is we're gonna learn one last function in spreadsheet, and then we are done with all spreadsheet equations. Okay, so what you're going to do is you're going to go to Blackboard and go to content and go to regression. So if you're already there, you're already there. If you go all the way to the bottom, the very last one is the link to the video we just watched. And I said from 3 minutes and 50 seconds. That's where I started the video. But you can watch the one before that too. But where it really starts about the R squared is about 3 minutes in, 3 minutes and 50 seconds in. Right above that, you're going to see spreadsheet Linus function practice. Go ahead and click on that. Save a copy in your drive. And when you do, and you can actually type in it, it's your own copy, then type in Linus in the chat. And that's the last thing we'll do today. And I will share my screen in a second. Oh, I guess I still have the colored stuff in there. Okay. And then keep your Mathplosion open. And if anything, you should actually go to this particular chapter. But you can just scroll up if you already have Mathplosion open. It's like 28.2 for now, okay? So what this function is going to do, it's very simple. All it's going to do is that it's going to provide us with a lot more information than just the slope and intercept. And so you can actually use this function instead of using slope and intercept like separately. But if you want to do predictions, it's actually good to do that. But anyways, Linus is kind of like a shortcut way to get all the information that you're ever going to use for a regression line. Okay. All right. So let me share my screen. Share. Okay. So we have this. And it's probably colored. It's from like my old thing. And what we're gonna do is we're gonna literally do what it's telling us to do in the chapter, okay? Let's go even exactly the same as what it's telling us to do. Let's go to E2, cell E2, and we're gonna do Linus function, right? And you can kind of imagine that it's trying to draw that line. And that's what it's from, okay? And then we're gonna do, always remember, we're gonna do the Y first, the Y data first. And then we're gonna do the X data, and then we're just gonna do something where it says true and true, okay? So that's the function. So where am I? Right here. So it's actually right next to that colored orange thing, E2. So go ahead and do equal, and then do Linus, and it would say best fit linear trend, right? So that's another word for regression. The least squares line is also another word for regression, okay? Just so you know, but you don't really have to like memorize those terms, okay? So Linus, I opened and closed. I always kind of like to do that in advance, okay? I'm going to select the Y and drag it down, right? Then you see that it's B2 to B6. I'm gonna do comma, and then I'm gonna select the X, okay? And then I'm gonna do comma, and remember it was capital true, comma, true. And you'll see that it actually will take on a color because Google Spreadsheet is recognizing this as an argument, as some kind of command. And then go ahead and hit enter. And what that's gonna do, if it does it correctly, it's going to give you all kinds of numbers. It's gonna give you all kinds of numbers, and these are very useful numbers for us, okay? So what your job is now is you're going to scroll down and you're gonna use this chapter to fill in the blanks. So you're gonna label these numbers, okay? And then we're gonna talk about it afterwards, okay? So go ahead and do this just like it does in your textbook. Go ahead and have this here, and then have this on the side and type it in. So it's actually highlighted for you because I have it from like the previous section. So type in like slope M, right? So that means this one is slope M, like in that direction. And it's kind of like funny, but then the 39.8 is actually your intercept, okay? Intercept here. And go ahead and fill out all of them just like it is done here in Mathplosion. So you're gonna fill in all of these things, and you'll notice that one of the numbers is R squared, okay? All right, so go ahead and fill those out so you can have a copy yourself. And once you labeled all of those numbers as it's shown to you in the chapter, type in like cells in the chat because you filled out all the cells. Oh, that was quick. Zach and Yasmin are already done. Maybe I'll like fill it out too. Squared. Yep. Intercept, standard error, B. Okay, most of you guys are finishing up. That's good. So if you're done, it should look something like mine now. This, right? So we have all these things labeled. What you really need to know is you obviously know what a slope here is and the intercept B, and now you're familiar with the R squared, right? And the next thing you need to know, only because it helps you quickly identify things, is if you go to the chapter and scroll down where it's everything is labeled, it actually explains what everything is, right? So the slope intercept, we know R squared, remember how scattered the data is from the prediction line. And then what's really important is that you don't really need to worry about the other thing, but what this F statistic is going to do is that it's going to help you use it for p-value calculations. So remember, in regression, in hypothesis testing, we got the p-value, the area under the curve, and that would help us reject the null or fail to reject the null, right? In terms of regression, we kind of had this overall significance test. I don't know if you remember it, but if the p is less than 0.05, then it's like, okay, go ahead and use that regression equation. It's good to go, right? But if the p is equal or greater than equal to or greater than 0.05, then probably you should not use the regression to make predictions, right? That's what the overall significance test was. And what's great about this F statistic is that if we have that number, then we can use this fdist function that's going to calculate that p-value for you right away, okay? So let's test it out. What we're going to do is that we're going to use this green boxes here to do the p-value, okay? So I'll write down p-value right here. And then what we're going to do is we're going to click on that second green box and we're going to do equal fdist. And I'm going to open and close like I always like to do. And then I go back inside the parentheses. And then you'll see that the first, we call them arguments. The first argument you put in this function is f, the f value, right? So then you can just click on that one right there. So it register that number. And then you comma. And then it says the number of x variables. So we've been only dealing with one x variable, right? And we're only, in this class, we're only going to deal with one x variable with one y. So the number of x variable is 1. So you put that in. And then comma. And you might remember this. We were dealing with degrees of freedom a little bit. But anyways, that's also available for you here. So you can either type in 3 or you can just click that cell right here. And then once that's all done and your parentheses are closed, then you can do enter. And that will be your p-value. And your p-value is 0.03. And you can be like, oh, well, that is less than 0.05. And so from that, I know that I can go ahead and use the regression line to make predictions. That's a good indication that you can continue with this regression line because it's going to be a good regression line, right? We had that overall significance test, and basically it's whether something is lower than this threshold, 0.05, the significance level, or if it's equal or greater than that. In terms of hypothesis testing, that's kind of true as well in a lot of fields, but we kind of broke it down a little bit more to very strong and strong evidence to reject the null. And then we have these like some evidence against it, moderate evidence against it, and a little evidence against it. That kind of all falls into this category because it's greater than 0.05. But depending on the research area, some people like to still accept, still like reject the null when it's still close enough to the 0.05. But that kind of phrase of close enough to 0.05 depends on which research area you're in. I might have mentioned like, you know, if it's predicting something like whether maybe the MBA scores, like the problem we did with the MBA score, average scores went up or decreased, that may not be like a life and death situation. So it's not that crazy if it's like close to 0.05 or a little bit higher. But if we're talking about like vaccines for coronavirus, this is like a literally a life and death situation, right? So maybe we want to be a little bit on the stringent side and we want to really have strong evidence against the null, or something way smaller than 0.05 p-value, so that it is good to use the information we have. Okay? All right. So that is the last two functions that you will learn in this class, which was linist function and then the fdist. But I think we used fdist before as well. Okay, and I'll collect all of the equations that we ever used, starting from, I think the very first one we might have done was equal average. And then maybe the next one was equal mode. Maybe we did do that, mode and median. Anyway, starting from all the way that, and we did normus dist is probably the one we use the most. We did t inverse, t dist, now f dist, and linist, slope, intercept, and all of that. So there's quite a few. but you know, still like 2 handfuls maybe. But the last 2 that you have learned was today with Linus and FDist. All right. Any questions on those? 1:45. So maybe I can let you guys a little bit out early. Okay. So this is what you need to do now by next class. Okay. So I don't know if we talked about it in the last section, but remember, unfortunately, the problem set 8 or something was actually due on December 2nd by accident, by my fault, not by accident, but I didn't tell you that you needed to do it. So I extended that due date. If I didn't, I'm extending it now. I'm telling you now. And that's going to be due, doesn't really matter. I did change it on Blackboard that it's due like next week on the 9th. But as you know, with Lumen and all these different compatibility issues, it might still grade it as late, and it's just going to be unattempted things. So go ahead and just finish that when you can. And then if you do actually finish it and receive a grade of 0, which I think you will, then you'll get full credit. Okay. 0 actually means 100% in this particular case. Okay. So go ahead and do that. And then one more thing you need to do is go to MA222 OER, and you will see, so that's problem set 8 that says HT means MLH, and then problem set 9 is available as well. Go ahead and start that. I have set the deadline for that as December 14th at 8 p.m. Okay, I'm just it's giving you a lot of time so that I don't mess it up basically. Okay, go ahead and start that. And if you can finish it, that's good too. But what we're gonna do is next class, I'm gonna go through some problems and problem set 8 and 9 and address some of the problems, and we're just basically gonna do some problems together, okay? And then on the 11th and 16th, I wanna reserve that to do basically an entire review from starting from all the way from the beginning of the semester up to the Linus and FDist that we did today. Okay, are we clear? So it is due December 9th. Your problem set 8 is due, but remember it's ungraded attempt, so it's gonna show up as 0 points or something. As long as you finish and do it, whether you get it wrong or right, everybody's gonna get full credit. And then go ahead and also start problem set 9. And if you can bring questions to me for the 11th, did I say that right? Or the 9th, then that will be excellent too. But I'm gonna go through some questions together in class. All right. Yes.
So the final is gonna be it's gonna be like including everything from like the very beginning.
Mm-hmm. Yes, correct. All math finals are like that. That's a departmental. It's like an FIT policy. Just so you know, moving forward, if you take another math class. Okay. All right, guys. Well, if you don't have any questions, I'll let you go early. Bye bye. Have a good weekend. Stay strong.
Thank you.
Bye.
Thank
Oh, and we'll do the screenshot, okay? We'll do the screenshot next week. I'll send out an email.
Bye.
Bye.
Professor, I have a question.
Nikki, by the way, I love your jacket.
Thank you.
Really good color on you. I love it. I will never be able to post something like that off. Anyways.
So like for problem set 7, this is like a long time ago. I remember like you said like there was like I completed it, but it's still like 7 out of 21. I don't know if that like means anything. Or
Yeah,
if, like,
yeah. I will fix all of that too. Yeah. What did you actually get? I'll fix it like right now, actually.
Let's see.
Or do you? It doesn't show. So sometimes it seems like on your end, you guys can see a grade, even though after it's ungraded and stuff. Doesn't matter because
It was like, I don't know. I remember I did it and it was like 21 out of 21, but I'm looking at like the practice. Oh yeah, the practice.
I'll put in 21. It's fine. Okay. Like, don't worry about it. I believe you.
Okay. Thank you.
I'm like totally doing another thing next semester with this Lumen thing. It's just like, it just doesn't work with Blackboard. It's like terrible.
It's a good tool. I think that it helps with like homework, but I don't know.
So next semester, maybe you're not interested, but you can make an Lumen account and it's free for students. So you just go into Lumen directly. I don't bring it into Blackboard because all of this is, I think, happening because I'm trying to bring it into Blackboard, which is a feature they offer, but obviously it's not working.
Hmm.
Yeah, so that's what I'm gonna do. But I don't know what that means in terms of grading. You can only see it in Lumen and may not see it in Blackboard, so we'll see what happens.
Hmm. Thank you. Have a nice
Okay.
week.
Have a nice weekend. Bye.
Bye.
Kaylin, Wei Yi, and Sienna, any of you guys have questions before I end the class or end the session? Problems at 6. Okay, then I'm gonna go ahead and close this class. Have a good weekend, guys.